Again, I've taken a quadratic equation that we've done before with graphing. Our coefficients, again, are 1, -2, and -8. We're going to take the turning point and the axis of symmetry. That would be -b over 2a. Our negative is part of the formula. Our -2 is our coefficient over 2 times the quantity 1. This would turn into a positive 2 over 2. Our line of symmetry is 1. So we can graph that, and that would be our mirror. That's where our mirror would be. That's our line, that's our axis of symmetry. That would be x is equal to 1. Okay, with that, we can plug in the value for 1 into our equation. Y equals 1 squared minus 2 times 1 minus 8. Y equals 1 minus 2 minus 8. Y equals 1 minus 10. Y equals a -9. So our turning point is at 1, -9. And we can plot that. So we would have 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's our turning point on the axis of symmetry. This is an upward pointing parabola because this coefficient is positive. So we have a minimum point. That's a minimum point on that parabola. Our next step is to find the roots where the parabola crosses the x-axis. I'll do it with this formula this time, but you really have your choice of several different ways of getting those solution sets for the roots. I'll just show you this different way, but whichever way works for you, that you're comfortable with, that's a great choice for you personally. I'm going to substitute my values into this formula, this all-purpose formula, and go negative, that's part of the formula. B is a -2, plus or minus the square root of -2 squared minus 4 times 1 times a -8. All that is divided by 2 times 1. Now I get to do the math part on this. Here's 2 signs in a row, so this turns to be a +2, plus or minus. We have 2 roots. There's a possibility of having 2 roots. That's why we have a plus and a minus on this. -2 times -2 is 4, minus 4, -4 times 1 is -4. So we have -4 times a -8 over 2. 2 plus or minus the square root of 4. Negative times a negative is a positive, 32, divided by 2. 2 plus or minus the square root of 36 divided by 2. Well, that's nice. This is a perfect square. So let me get some, this turns into 2 plus or minus 6 divided by 2. All right, now I need just some board space, so let me take 6 over 2. We now can separate that into 2 different problems, 2 plus 6 over 2 and 2 minus 6 over 2. This is going to give us our 2 roots, our 2 places on the x-axis where the parabola crosses. So 2 plus 6 is 8 over 2, and this would be -4 over 2. Reduce our fractions. This is an and. This is 4, and this one would be -2. So our x-intercepts are 4 and -2. And in this case, we would have our ordered points as 4 and 0 and -2 and 0. And now we can plot those. So we would have 1, 2, 3, 4, and -2, 1, 2. There we go. And we can check this really quickly to see that they're both the same distance from the line of symmetry. 1, 2, 3, this goes over 3, and 1, 2, 3. Good. That's perfect. Our math must be right. Okay, so now we've got our parabola. We could connect our points here. This goes down. Here's where we swing upward. Here's our parabola taking shape. It's already crossed the y-axis. We just need the ordered pair. So we can put our ordered pair, which is the x is 0, and now we're looking for that number right there in our ordered pair. So we just put that back into our formula. This is an easy calculation. And go y equals 0 squared minus 2 times 0 minus 8. Well, our zeros cancel out, so we have y is equal to a -8, and there we found it. So our y-intercept is at 0, -8. And you have all of the important pieces to this parabola. Most of the questions will be something to do with these important points on a parabola. Now you know a couple of different ways to do this, but the one that works for you is for you to determine.